Hey guys, how's it going? Today we are looking at the Cherry Mint Low Miles 351 Windsor out of a badass 70s or 80s Mastercraft ski boat. And what I really like as an engine builder to see on these old engines, we'll start up here. Look how clean everything in here is. There's no sludge. It is just bare, nice iron. There's no rust. The outside is gonna get dirty and rusty, that's fine. But as long as, let's roll her over. Look how clean this is. This guy definitely took care of this engine. There's not a speck of sludge in here. This is gonna be so nice to take apart. And look at this. Oh, see if y'all can see that. The skirts still have the original mill marks on them from when they were cut. Like, this thing has been well maintained and taken care of. We're gonna rebuild this motor. Just do a basic rebuild on it, mild cam, bump the hone, which is gonna give us some new crosshatch on the bores. And I won't know until I get it taken apart, but we think we can still reuse the pistons just because of how clean everything looks. I mean, there's no ring ridge right here, other than some of that carbon buildup. Normally, on an engine that's very worn out, you'll be able to feel what's called the ridge. And it's a very pronounced ridge. And what that ridge is from where the rings are wearing away that bore. But the ring only goes up to the very top. So there's usually a ridge there that's unworn by the rings. However, this engine has absolutely no ridge. So this is gonna be a very nice rebuild. New cam, new rings, new bearings, nice paint job. It does have one of those AutoZone fix-it rubber stoppers in one of the freeze plugs, so we'll get that fixed. Hopefully the block is okay. If not, you can drill it out for a Chevy size and be fine. But I'm gonna get the time lapse going, get this thing ripped apart, and see if we have any updates or findings along the way. This is easily one of my favorite tools in the shop. Boom, done. First sign that somebody has been in here before. There's RTV underneath the harmonic balancer bolt. And I know Ford did not do that from the factory. So this engine has been rebuilt before. That's not an issue though. If anything, it only helps us since it's been rebuilt at one point in time. We'll keep getting it torn down and see what other mysteries we find in here. Oh, that feels so smooth to turn over. Good. This will be nice. All right, we'll start by busting the rods out of it. I usually write on these little pads which cylinder these rods come out of, especially since we're going to reuse the pistons. I want to make sure that the pistons go back into the bores they came out of, just to make sure everything, because we know it ran. It was a running engine. It's obviously not hurt, and so no reason to mix it up. We'll just put it back together the way we found it after we do the new rings, new bearings, and all the new gaskets. Right now I'm just using some brake clean on a rag to wipe off that little pad so I can use a paint pen to write down the number. So we actually have cylinder 1 here, cylinder 5 here, number 2, 6, 3, 7, and 4, 8, because it is a Ford. Fords are different than Chevys, believe it or not. Crazy, right? Ford being different. Who would have thought? All right, here's our first main bearing. Or rod bearing, I'm sorry. We see a very nice, what I'm looking for is I don't want to see a very narrow wear spot, and I don't want to see wear spots only on the sides up here. What I want to see is a very nice concentric wear spot all the way around the bearing. That means the journal and the crankshaft is straight. That means this bearing cap was machined straight. This is really good looking. Let's see what size bearings we have. We have 10 bearings. Someone has definitely been in here. So the crankshaft is cut 10. Okay, that's not a problem. Especially with how straight that wear is. They did a good job cutting it true. So we'll put this back in here for future reference so we can get the right new bearings ordered. Let's see what this rod looks like. Rod and piston, I should say. All right, I'm gonna have to hammer that out, I think. Can't quite push it. Let's just give her some little love taps. There she goes. Oh, look at that. Push the handle through. Okay, there we go. All right, same wear pattern on the top. Everything looks good. You know what? These are not standard pistons. This is definitely, yeah, we've got 40 over pistons in this. I didn't look close enough before, but you can clearly see, you might not be able to on, oh. See that 040 right in the right light if you squint your eyes? Okay. Not a problem. But yeah, look at the skirts, man. Let me get a rag. Look how clean that is. Whoever rebuilt this did a good job. Everything looks super nice. Cool. Rods look good. Another set of 10s, obviously. All right, I'm gonna slam this thing out. Give you guys an update in a second. Also, when you do rebuild an engine, the rod and the cap are machined together. So when you're rebuilding it, you have to make sure the rods stay, the cap and the rod stay together. You can't mix them up. It's not an option. So normally, you do it the previous rebuilders did, and you just stamp it. And it looks like originally this rod, that's funny. They stamped it 2 and 2 for cylinder 2, but it came out of cylinder 5. So that is interesting. But it came out of 5, so I'm gonna put it back in 5. But we know this rod and cap go together because it's stamped 2 and 2. This is the first piston that came out of number 7 that was actually labeled number 7. Funny how that works. Cylinder number 8 that I pulled out. W. I like it. W. Wonder what that stands for. We are going to update this link chain to a double roller, and we're going to put a new camshaft in it as well. So, because this thing is really stuck on there. Normally they just boop, pop out. This is my experience. Okay, there's that one. Chain off there. And then this one, I'll have to use a gear puller on. Here's our gear puller. Boom. Oh no, you'll hurt the chain. You'll hurt the sprocket. Don't do that. Okay. Come on. There it is. It's all right, guys. We're going double roller. This is machine steel. You're not gonna hurt anything prying on it. All right, let's get our crank out. Really curious to see how its bearings look. This little stud right here, y'all see that? Not really. That little stud is for the oil pump pickup. Because it's a boat motor, the load varies of where inertia is going to be as the boat's rolling and rocking through the water. So to make sure that the pickup is always surrounded by oil, they put the pickup right in the middle of the oil pan. And because the pump goes way over here, it has a real long tube that snakes around. To give that tube support, it has a little tab that goes there, and another nut bolts it to that pickup, to that stud. So that's what that is. Well, that's pretty neat. Fun facts. Oh, that's tight. Somebody likes anti-seize. All the caps had a nice press fit. That's good. Main bearing number 1. Perfect. Totally golden. And what is our crank cut? Our crank is also cut 10 on the mains. Good. The reason I'm curious about that is normally, let's say you spin a rod bearing, right? Let's say you spin this bearing right here. Well, normally that rod bearing is going to be totally destroyed and may need to be cut 10, 20, possibly 30 thou. But your main bearings are okay. So what you would do is you'd cut all the rods, 10, 20, 30, however far it needs to be fixed. And then your mains, you could just cut 10. Because they're not messed up. Or you could leave them where they are and just give them a nice polish. So because it is 10 on the rods and 10 on the mains, that means we never had a catastrophic failure in this engine's life to necessitate cutting everything up. So, good news. This is what a healthy engine looks like inside. I'm also curious who rebuilt it. It's always fun to know what other people have done, or the history of the motor is always interesting to me. Yeah, all the bearings look very nice. Yeah, man. Everything looks really good. Let's see if the other side of a two-piece seal is as stuck as the front. No, not as bad. Interesting. Oh well. All right. I'm gonna bust off this thrust plate for the cam. Wrong bolt. You think I know them all by now. Oh, hello. There we go. Camshaft feels really good. Gear looks good. Yeah, all the cam bearings look awesome. I'm gonna get this block loaded up in the jet wash. Actually, nope, we gotta knock out all these freeze plugs and also see what mystery lies behind our rubber stop a leak. To knock freeze plugs out, I just use a rounded off chisel. And I will take said chisel. Let's get you guys set up. Whoa. Come right here. And knock them in. That is ideal. That's what I try to achieve. Where it's still in the board, the other one just fell through. Press pliers, grab it right there. Use the block itself, boop, pops right out. This one we can kind of, before we lose it totally, come here, grab it, oh, come back. Kind of get it started. Same process, boom. Oh, come on. There it goes. Pop out. Now let's see what's under you. Which is what I'm very curious about. Hopefully, they just didn't want to mess with slamming in a new freeze plug. So they just used one of those kits. Which obviously works. I mean, if you're in a pinch and you can't get to it, because this did come out of a boat. And oh my gosh, the headers are, I'll have to show you guys later, but the headers are just absolutely massive because they have to fit. A whole bunch of water has to go through them. Come on. Man, you're really in there. Let me get a flathead. See if we can use a little more leverage. There you are. And then we have the other side. No, come back, come back. Where am I needle nose? Uh-oh. There we go. Okay. If you haven't seen one of these before, you have a threaded stud on one side with a washer, and normally that's supposed to be tacked on right there, but oh well. That washer goes into the back side of this rubber plunger, and on the front side you have another washer and a nut, and you stick it in the hole, and as you tighten that nut down on the stud, it compresses the two washers and opens up the O-ring to fill the hole. Let's hammer out this side, see how they go. Nice. That is exactly how I like them. One. 2. Oh, last one. Always giving trouble. There it goes. All right, we got all those out. Normally, if this engine had never been rebuilt, these drain plugs are usually welded in there from the rust. So let's see how difficult they are to pop out. We'll start with T-handles at first, just so I can get a feel for it. Nope. Awesome. Not bad at all. Okay, let's see what the other ones are. You look a little toasty. You look a little rusty. Yep, you are rusted. So, I can't get it loose with my hands. Just one more time. Oh, there it goes. Smell the rust coming off of that one. Give her some liquid motivation. We'll kind of back it back in just a hair. And then we'll loosen it back. And boom. Just a squirt of WD-40 makes a huge difference in pulling those plugs out. So we'll chase all the, we'll retap those to get fresh threads. And then we'll also chase everything once I jet wash it, just because I don't like working around all this grease and dirt. All right, next we're gonna knock out the old cam bearings. Super easy to do. We'll take our long boy stick here, shove it in there, tighten it up a little. And then one is out. Two's out. I'm gonna move you guys out of my way. Three. And number 5. All right, we'll add this into our parts to wash. We're not reusing these, but it's always good to keep the old parts so the owner can see that you did, in fact, replace the cam bearings. So I'm gonna do a quick razor blade scrape down, get all the old gasket junk off, and then we'll move it into the parts washer. This is my favorite tool in the shop. And yes, I have 2 favorite tools, but this is literally called the Super Scraper. It's got a carbide tip that's cut perfectly at 90 degrees. And because it's carbide, it's harder than any engine material you'll work on or use it on, if you use it right. And so it just takes off that small residue. And because it's carbide, it'll stay sharp forever. And because it's precision ground, it won't file it in a weird angle, and it'll just do a nice straight, clean pass on it. All right, we got the oil pan cleaned all up. Come in here, take off the RTV from those rear main seals. Finally got that gasket knocked off. What's interesting is we've got a threaded pipe plug there. On the OEM Ford blocks, they're press-in. However, because the distributor gear is right here, by design, it does not get a lot of oil, just being due to the fact that it's in the front of the engine. So all the inertia is going to push the oil towards the back, and there's nothing really up here to splash oil onto it. So what most shops do, and what I highly recommend, and what I was planning to do already, is you drill and tap that for a plug, and then in the plug, you drill a hole through it. And so that hole will spray oil out of it to give the distributor gear much better lubrication. I'm gonna get it off the stand, put it on my table. I'm gonna knock out these two last plugs from the back side. There's some way back there, and you can stick a long rod through the block to hammer the plug out the front. So we're gonna get the plugs knocked out, throw it in the jet wash tank, and let it bake in there while we tear the heads down and see what their story is. It's always fun rebuilding motors, right? Because you'll see, you got the plug drilled, they did some good stuff inside, but then they used the cork gaskets here. Guys, don't use these gaskets. They will leak. What you're supposed to do is just do a nice bead of RTV on the china wall here, and that will never leak. However, the cork stuff, oil will seep through, and it will leak. Let's get her loaded up in the jet wash now. I'm not going to clean the decks off because we're just going to surface them. Alrighty, while our block is getting all washed up, I'm gonna start tearing down these heads and see what kind of secrets they have inside of them. Other than the normal buildup of carbon, our valves look awesome. Because this guy's not looking for maximum performance, and he doesn't want to spend a whole bunch of money, on a set of factory iron heads, I'm gonna make sure the valve guide clearance is correct, but I can tell you right now it will be. And we'll get these valves cleaned up. We'll lap all the valve seats in. I'll show you that in the next video. And we're just gonna put these right back in. While we still have the other parts getting all cleaned up in the jet wash, I'm gonna go ahead and get these old piston rings off so we can get these pistons soaking in a cleaner to get all that carbon off the top of them. Now that I'm close to finishing getting all the rings and the rest of the bearings out of these rods and pistons, my thought is still the same. This stuff looks really clean and really good. The ring wear looks normal. These bearings look really good. All in all, this motor was a very healthy engine. It just had a few oil leaks from some in superior gaskets, but we'll get those all fixed up and get this engine back on the water. So while I was going through everything, I did notice that our distributor gear does have quite a bit of wear on it. Right there. So we will have to be replacing this gear. It's just held in by a roll pin. So we'll knock that roll pin out and start pulling the gear out. Hey guys, I went ahead and finished cleaning everything else up off camera because it's cleaning. It's not very exciting. So I'll just wrap it up really quick. I'm gonna take the heads, valve covers, oil pan, valves, block, this giant iron timing cover, iron intake manifold. I'm gonna take those to another local shop to get sandblasted and thoroughly cleaned to get all the rust and paint off everything. And then over here, I got all 8 rods semi-cleaned up right now. Got all the oil and grease off them. There's still all the carbon on the pistons. So I'm gonna soak these in the ultrasonic cleaner and start getting those cleaned up tomorrow afternoon. The caps are clean, the distributor gear's off. And then I think that's about it for the 351 engine. I just gotta drop that stuff off and then I'll have an update for you guys when I get it all back. But in the meantime, I wanna leave you with the image of this. Here's that 572 blower. I kind of showed you all a little bit the other day. It's about to be dynoed. Tomorrow is when I'm going to dyno it. It's got a 2-tone powder coated valve covers and supercharger. Really cool, badass engine. This thing is an absolute mammoth. It weighs like 850 pounds. It's gonna make 900 horsepower. And no, I know you can make more with a turbo LS for a quarter of the price, but look at it. Does your turbo LS look this cool? Check it out. Anyways, guys, I'll see y'all later.